equations. Okay, that's the basic concept that you need to be aware of. You must have understood linear equations. Now, when you are solving literal equations, you won't have a specific value for the variable. You solve for the variable, but your answers are going to be in the form of letters. Okay? So I'm going to start with a very simple example from what you know from grade 8 and 9. Okay? So I'll just start with a simple example. Okay? Examples. Right? The basic idea is solving equations, as I say. Right now, in grade 8 and 9, you were finding the area, say, of a circle. Okay, or maybe we'll start with a circle. The area of a circle A was equal to pi r squared. Okay, now we can make here r the subject of the formula. Okay, what that means is we can write this equation in such a way that the r will be on the left hand side. Okay, by doing that, we'll be making r the subject of the formula, or we'll be making the radius the subject of the formula. We are not solving for the value of the radius, but we are determining a formula that we can use to determine the radius. That's what literal equations are all about. So here, if I want to carry on to do that, to isolate the r, or to make r the subject, the first thing that I have to do is to divide both sides by pi. So this becomes a over pi is equal to pi r squared over pi. Okay? I want to isolate the radius. And the radius must not have the square. It must not be squared. I only want the radius with an exponent which is equal to 1. So first thing, divide both sides by pi. Okay? Then, after that, we end up having a over pi is equal to r squared. Okay? Then the next thing, how do you remove this 2 here? From your knowledge from previous grade, how do you eliminate that 2? You what? You square or you square root? You find the square root of both sides. Okay? If you want to remove the square of any variable, you just find the square root on both sides. So my next step would be to find the square root of a over pi. And that square root, we also square the left-hand side. So when you do that, we end up having the square root of a over pi is equal to the radius, which I can write as r equal to the square root of a over pi. This equation here, that's the equation that we can use to determine the radius, as long as we know the area of that circle. Okay? And this is part of what are called literal equations, because we are not finding a value for the radius. We are only writing a formula that can be used to determine the radius. Okay, so we use knowledge of equations, knowledge of exponents to do that. Okay, now this is literal equations are very important. Okay, I think all of you are doing physical sciences. You encounter literal equations in physical sciences a lot. Okay, so that's one example. Okay, let's move on to another one. Let me take the second example from everything net. Okay, whilst I'm doing that, is there anybody who has got a question? Okay, let's do a second one. It's an easy one, then we will move on to more challenging one. Another example, we have got V equal to U plus AT. Okay, that's a physics equation for equation of motion. Right? So we want to make T the subject. Okay? We want to make T the subject. Now, if you want to make T the subject, the first thing that you have to do is to do what? We want to isolate the t. What would be the first step? Yes? Okay, it will be specified in the question. Okay, make t the subject. It will be specified in the question. Make t the subject. Okay? Don't worry, it will be specified. Or another way to be to say solve for t. Okay, let me use a different color there. We are solving for t. Solve for t. That's another way of asking the question. So I'm asking you, if I want to isolate the t, what will be my first step here? Yes? Before division, what is the first step? Okay, listen, don't complicate things. You have solved linear equations. You have solved linear equations. If this u was a specific number, like say a 10, how would you carry on? Huh? You take the 10 to the what? To the left or to the other side. The same ideas that you're using when you're solving linear equations will apply here. The only thing that we don't have numbers. So if I want to solve for t, first thing, I'll take the u to the left, like that. That's the first step. We want to solve for t. By solving for t, it doesn't mean that the answer that we are going to get must be a number. No. It does not always have to be a number. Okay? It can be a combination of letters, like how we are going to get the answer here. We want to make t the subject, or want to solve for t. Okay? This equation is a linear equation because the exponent of all of them is equal to what? 1. So we take the u first to the left, then we'll be left with at on the right. Then how can you carry on here for you to be able to be left with t only? You divide by what? By t. So first step, you take the u to the left. Next step, divide both sides by a. So this becomes b minus u over a is equal to at over a. Then these two cancel out. So the final answer will be t equal to b minus u over a. Okay? So I've solved here for t. By solving, I need to emphasize this. When you're doing literal equations, it doesn't mean that you are supposed to get a specific value for the variable. No. It means you're just finding a formula for that specific variable. So this formula here can be used to determine the time. If you know the velocity, the final velocity, the initial velocity, and the acceleration. Okay, don't worry about those terms because you are going to encounter them later on. All right. Okay? All right, another example. Another example. Right? Solve for y. Solve for y. The equation is just give me a second, I need to recalibrate my video. Okay, so we are solving for